Welcome to qnawire.
Hi, so over here, remember that we know that delta U is equal to Q plus W with this same convention. And in this case, we're told that delta U is equal to 0 for an ideal gas, since the internal energy is going to be only a function of temperature. So for an isothermal process, the change of internal energy should be equal to 0. That means that the reversible heat for the isothermal process would be equal to minus W. For us, the value for W is equal to minus the integration of PdV, which for an ideal gas would be equal to minus the integration from the initial volume to the final volume of nRT divided by B differential volume, which yields nR minus nRT logarithm of B2 over B1. So the value for the work would be equal to minus 0.5 moles times the gas constant 8.314 joule per mole Kelvin times the temperature, which is 298 Kelvin, times the logarithm of 20 divided by 10, which is logarithm of 2. With this, the work would be equal to 858.66 joules of work with a negative sign. Okay, that means that the reversible heat is going to be equal to 858.66 joules. Thus, the change of entropy for the system is going to be equal to reversible heat divided by the temperature. The temperature is 298 Kelvin, which is 2.88 joules per Kelvin. So now we have answer for part A, the delta S for the system. It's going to be this part over here. How much work is done on the gas? Here we have the work done. And we have how much work done on the gas we're going to have. Now we need to calculate what is the heat of the surroundings. In this case, the heat corresponding to the surroundings, since we provided heat to the system, would be equal to minus 858.66 joules. What is the change of the entropy for the surroundings? And this needs to be equal to the negative of the change of entropy for the system, joules per Kelvin. This was supposed to be a K, not a W. Okay. And finally, what is the total change in entropy of the system plus the surroundings? So total delta S would be equal to 0. And with that, it would be all. Thank you very much and have a good one.